All right. This last two pages of this review. First problem here, number 31, is an arithmetic sequence. It's been a while since we did this, but remember you all kind of said, that those are pretty easy. So find the next three terms in the sequence. So first find the pattern. This one is that you add 3 every single time. And if you're not quite sure what it is, you get the pattern for an arithmetic sequence by finding the common difference, and you just subtract any two consecutive terms. Make sure you do them in order, like third term minus second, whatever. So the fact that this keeps being 3 means there is a common difference of 3. So if I just add 3, the next three terms would be 14, 17, what's happening with this pen, and 20. So those are the next three terms. And then determine the value of the 50th term. So, excuse me. So you don't want to keep adding 3 until you get to 50, because I could also say, what's the 500th term? So to discourage you from doing that. So what do you need to do? There's a quick little formula to memorize. To find any nth term, you start with the first term, add n minus 1 times the common difference. This is just like from the first term, how many times do you need to add 3 in this case to get to whatever term you're looking for? Okay, so for us, we want to find the 50th term. Our first term was just the first number in the sequence was 2. We're going to add 50 minus 1, so 49, times the common difference, which was 3. So you've got to do a little bit of work off to the side here. 3 times 7 is 27. 3 times 4 is 12, plus 2 is 14. So I get 2 plus 147. So the 50th term, 2 plus 147, is 149. All right, so make sure you memorize this little pattern for an arithmetic sequence, and that's definitely a non-calculator problem. Okay, now we have some functions that we're going to combine, and of course, everybody's favorite, we have to write domain. So let's write the domain to begin with. The domain for f is all reals because it's quadratic, and the domain for g, we've done this a lot now, x plus 4 is greater than or equal to 0, x is greater than or equal to negative 4, which would be negative 4 to infinity. All right, so writing the function is the easy part. F minus g is just 2x squared minus the square root of x plus 4. So that's it for the function. And then what do we do about the domain? So remember, the domain is like, where do these domains overlap? So f is all real numbers. And then g is saying, okay, anything from negative 4 to infinity. So where do they overlap? They overlap at negative 4 to infinity. And then the only other thing you need to consider is if there's an extra domain restriction. Now, really, that only happens with division and composition. All right, so let's look at division here. F over g would be 2x squared over the square root of x plus 4. And we can leave our answer like that. We don't need to rationalize. Now that the square root is in the denominator, it's really that x plus 4 can only be greater than 0. So remember, you should just be making slight adjustments to the domain you had for any combination. So instead of square brackets negative 4 to infinity, it's parentheses negative 4 to infinity, because that leaves out x equals negative 4. But it goes up to like negative 3.99999. All right, for composition, this is composition, by the way. A few of you were showing that it was multiplication when we had a quiz on this. So open circle is composition. Multiplication would look like just fg of x. And when you're doing composition, remember, you need to keep the domain of the inner function into your final answer. So because the inner function is the square root of x plus 4, negative 4 to infinity needs to make it into my domain restriction for my final answer. Okay, so plugging that into f, it's 2 times the square root of x plus 4 squared. And when I square a square root, I just get the expression. Now be careful, it's in parentheses. So that 2 being multiplied through would be like 2x plus 8. Or you could leave it in parentheses. I just mean it's wrong to say 2x plus 4. That's not right. Okay, and then like I said, get the domain in there too. There's no extra restriction on this. This is just a line, but the line only exists from -4 to infinity. So -4 to infinity is my domain, and that's my final answer for that one. We can also compose the other way. So this means g of f of x. F of x is the square root of x plus 4. Plug that into, let's see. Sorry, f of x is, I was going to say, why am I doing the same thing I was just doing? F of x is 2x squared. There we go. Plug that into g, the square root of, instead of x plus 4, 2x squared plus 4. Now, what about domain? Check the inner function. 2x squared has a domain of all reals, so far no issues. And normally in my final answer, I would say, oh, it's a square root function, so 2x squared plus 4 needs to stay greater than or equal to 0. But think about that. If you try solving for it, you'll get an imaginary number for x. Also, 2x squared is always positive. Adding 4 to it will keep this always positive anyway. So, all real numbers, there are no domain restrictions for this one. All right, and then I need to find g inverse and f inverse. So remember, the first thing is to make sure that g itself is 1-to-1. So do a quick little sketch of the graph for g. It's a square root graph. It's been shifted left. Opens like that. That does pass the horizontal line test. So we should find an inverse function. And then the other nice thing about doing this is, remember, you need the range of g, which is 0 to infinity, to get the domain of your inverse function. So, and you could write it down right now. Okay, g inverse is going to be something, and its domain will be 0 to infinity. So you can do that right away. All right, so what about finding the inverse? So g's equation is this. So switch the x and the y. X equals the square root of y plus 4. Square both sides and subtract 4. So y is equal to x squared minus 4. Now, a full parabola wouldn't work, but that's why our domain is just half. We're going from 0 to infinity, so half of a parabola will be the inverse of a square root function, which looks like a half parabola opening sideways. All right, let's do the same thing with f. So sketch f of x first. It's 2x squared. There are no domain restrictions on this f of x. It doesn't say x greater than or equal to 0. So actually this function is not 1-to-1. F is not 1-to-1. So that means that f inverse doesn't exist. You could just say no solution. I'm just explaining that further. Okay, number 38. This is one of the kind of longer problems. When you see the directions, part of this is studying directions. When they say this, I do this. So when you see verify, that kind of means prove. Verify f of x and g of x are inverse operations or inverse functions. So now I'm not going to prompt you like this on the test, but you need to know that this means there's that 3-step process that we do. The first step is f of g of x. So f of g of x is f of x squared minus 2. Oops, I wrote g, sorry. Is f of x squared minus 2. Plugging that in, you get square root of x squared minus 2 plus 2. Square root of x squared is absolute value x. And now don't say that, you don't want to say, oh, that's not x, these are not inverses. That might not be true, especially if you see a restricted domain. So consider this that it's simplified to x. And then number 2 is g of f of x, which means g of square root of x plus 2. So we are taking square root of x plus 2 and squaring it and then subtracting 2. X plus 2 minus 2, that does come out to x. So step 3 is checking domains and ranges. Remember, the diagonals should match up if you set it up like this. So what's the domain of f and the range of f? So f's domain is -2 to infinity. It's a square root function, so 0 to infinity is its range. And what's the domain of g and the range of g? the domain of G is normally all reals because it's quadratic, but here they gave us a domain restriction, so it's 0 to infinity. And then the range, because this graph has been shifted down to, is -2 to infinity. So the diagonals do match here, which means the domain of f is the range of G and vice versa, and that's the behavior of inverse functions. So f and G are inverses. Now, you can do these steps in any order, by the way. So a lot of times it's the composition that works and the domain and range that doesn't match up. So you could start there if you want to, but I just always do it in this order. 39 says find f inverse and its domain if f of x is this. And this is interesting. This is one of these half circles that we have, but they've restricted the domain. Normally this half circle goes from -5 to 5. So if we sketch this graph, a full half circle does not pass the horizontal line test. But if you just go from -5 to 0, then you have like a quarter of a circle, and that does pass the horizontal line test. So we are going to find f inverse. We might as well find the range for f because we're going to need that. So the lowest y value is 0 and the highest is up here at 5. To find f inverse, remember we take this equation and switch x and y. So it's x equals square root of 25 minus y squared, and switch the inequality. -5 is less than or equal to y, which is less than or equal to 0. This inequality is important because this really just says that y is negative. All right, so I'm going to square both sides to get rid of the square root. And instead of subtracting and then dividing, I'm just going to add y squared to the left side and subtract x squared to the right side. And then I'm going to square root both sides. When you square root, that originally generates a plus or minus. But remember, we have to choose one for this to be an inverse function. And we choose based off of this inequality here. That tells me to choose the negative because the y values are supposed to come out negative. Make it official by calling it f inverse of x. It's equal to negative square root of 25 minus x squared. And the domain is taken from the range of the original function, so 0 to 5. And our last page here is just a couple of graphs. So we've got 2 transformations to do. For this square root graph, the first thing is to, if you see a number in front of x and a horizontal shift, factor that number in front of x out of those 2 terms. So the 2 is still underneath the radical. It's just, this shows us how far we're not really shifting 6 to the left, we're really shifting 3. As far as the points go, every x gets divided by 2. Every y gets multiplied by -1. And then we're going to go left 3 and up 4. So remember, you need to know the square root of x points. You don't have to write all of these out for me. I'm doing that just for your reference here. So know these, or know that you should be plugging in perfect squares for x and getting their values. And then I'm going to do this math here. So that's still 0, 0, 1/2 -1, 2 -2, 4.5 -3. So I'm starting at 0, 0, and then I'm going to go left 3 and up 4. Start at 1/2 -1 and go left 1, 2, 3 and up 2, and up. I tried to skip too many steps. 1, 2, 3, 4. There we go. Now you can also do it this way. Like from 0, 0, you could say go over a half unit and down 1. From 0, 0, go over 2 and down 2. See how that's going to land me in the same spot? From 0, 0, go over 4.5 and down 3. That's probably faster than going to each one and shifting left and up, but you can do it however you want. And then that's a pretty good set of points. I know I could probably get more on here, but when I say I want as many nice points as you can fit on a 10 by 10 grid, I'm talking about the original parent function and then just transform those. Okay, our last graph is the x squared graph. So again, know the parent function first. And if you don't, just plug numbers into it. Plus or minus 1 squared is 1. Plus or minus 2 squared is 4. Plus or minus 3 squared is 9. And then we're going to go right 5 and down 2. The 1/2 that's out in front multiplies every y value by 1/2. So if you want to write these out, you can. You don't have to for a test or a quiz. I just kind of like to have the visual. All right. So 0, 0 is going to go right 5 and down 2. Let's use that trick that we did before. Instead of going to 1, 1/2, and then traveling right and down, just from the vertex, from where your vertex is, go right 1, up 1/2, and go left 1, up 1/2. From the vertex, go right 2, up 2. Vertex left 2, up 2. And then go right 3, up 4.5, and same thing on the other side. All right, so that finishes our last page of our review. Remember, the review covers everything that's on the test. There are no surprises on the test. This is much longer than the test. I think the test is 26 or 28 problems, not 41. So you've got lots of practice in the review. If you want more practice, we've got a domain and range packet. We've got a composite functions packet. We've had worksheets. Go back through homework, practice your calculator stuff. I think that's it.